Solutions. Solutions are mixtures. Remember that mixtures involve two or more substances that retain their own properties, but those substances can eventually be separated out without using chemical reactions. One separation technique that we've talked about before is evaporation, which will separate things like salt from water because the water will leave the mixture as a vapor or gas. A solution is not any type of mixture. Rather, it's a mixture that's usually liquid. It's homogeneous. Homogeneous means it looks the same throughout. And it involves dissolving things. When I say dissolve, what do you think of? I usually think of something like a cup of water, mixing something into it, maybe salt or sugar, which usually leaves the water clear if I mix it in really well. You can also think of Kool-Aid or like the little packets that we put in water bottles, and that might leave a color in it, but we can usually see through the water, and the color is even throughout, as well as the taste, right? We definitely want Kool-Aid to taste the same throughout the whole pitcher or bottle. In this case, and in most cases, water is going to be the solvent. The solvent is whatever there's more of, and usually it's the liquid you're putting something into. But you can dissolve liquids and gases, as well as what we were just talking about, which were solids. Water is called the universal solvent. That's because it dissolves more substances than anything else. So how do things dissolve in water and other solvents? Well, the substance that dissolves actually breaks apart into smaller units. So salt, like NaCl here, table salt, is going to break down into smaller pieces. If you were to put a cube of sugar into a cup and stir, that cube would slowly break apart until you couldn't see the individual molecules of sugar anymore. Same with salt. Eventually, those salt crystals dissolve until you can't see them with your own eyes. For sugar and similar molecules, they are going to separate into individual molecules, while for ions like salt here, they're going to separate into their positive and negative ions, which in this case is going to be positive sodium and negative chloride. For these solutions, the water is actually going to come in between these molecules or atoms, and we're going to just have water sitting between, kind of blocking these atoms from getting close to each other again. But water actually does more than just sit between these atoms. Water actually forms a slight attraction to these atoms. It's not strong enough to form a chemical bond, but it does form an attraction similar to a magnet. So remember that for ions, they have a positive or a negative charge. And water, at first glance, it's going to be neutral for the whole molecule altogether, but there are slight areas of positive and negative charge. Why does this happen? Well, it's something called polarity. Polarity happens because there's going to be an area where electrons are more often. Even though oxygen and hydrogen are sharing the electrons since they are nonmetals, oxygen has a higher electronegativity, which remember means attracting electrons to itself, and that causes it to have a slight negative charge. So this negative charge is actually what we call a negative pole. Negative poles form where electrons are experiencing more attraction, and this is caused by a higher electronegativity. So since the electrons are more often over at the oxygen, even though they're being shared, this leaves the hydrogens with a little bit more proton than electron ratio, and that causes it to be more positive. Not only are the water molecules sitting between these ions, they actually come in and they are attracting those ions, with the chloride being attracted to the positive end, and the sodium being attracted to the negative end. So water comes in and splits them apart. These poles are just like the north and south pole of the Earth. So this is going to be the negative pole, this will be the positive pole, and that's why we call substances like water polar. Water will dissolve substances that are polar, just like itself, as it attracts the positive and negative areas, even on molecules like sugar, because sugar has some areas of positive and some areas of negative slight charge. There are molecules that are not polar, and they are called non-polar. Non-polar substances like oil have their electrons shared evenly, and so they don't have a positive or negative area. They are neutral throughout. Nonpolar substances like oil will not mix into a solution with a polar substance like water, because the water does not get in between the molecules of the oil and cause it to break apart at the molecular level like it does with polar substances. You can dissolve nonpolar substances, but it has to be with a nonpolar solvent. When we say like dissolves like. Nonpolar substances like oil have to dissolve in nonpolar solvents, whereas polar substances like salt and sugar, they dissolve in polar solvents. If we want to know how much of a solute is present in a solution, we call that the concentration. So the solute is the substance that is dissolved. We usually say there's less of the solute and more of the solvent, and usually the solvent is water. So the solute has a concentration, the amount of solute per liter, which is like the volume of solution. You can have a highly concentrated liquid, and that just means that the amount of solute is really high in that amount of solution, and then you can dilute that solution to have a lower concentration by adding water if it's a water-based solution. You might have heard of things being diluted if you're thinking of cleaning agents or even something like juice. We usually hear orange juice from concentrate. That means we take a highly concentrated mixture of the orange juice, and then we can mix it back into a bunch of water and have more orange juice. So one way to decrease the concentration is going to be adding water. And to increase the concentration, we could remove water. And one way that we do that is called evaporation. So just like a puddle on the side of the road evaporating and then the road being dry, we could leave the solution to sit out overnight, over a couple of days, and you'll notice the water level goes down as that water turns into vapor or gas and leaves that mixture and goes into the air. And that'll increase the concentration of that sample, that solution. We can also simply add more solute. So if you want a heavily concentrated cup of salt water, you would just add more salt. The ability of a substance to be dissolved is called its solubility. Each substance has a solubility, but that solubility is actually different under different conditions. So one thing that can increase the solubility of a solid is going to be increasing the temperature. So for solids and liquids, as that temperature goes up, you're able to dissolve more of a substance into the same amount of liquid. So one example that I really like to use, especially in the South, we have our sweet tea. And when you brew sweet tea, you want to add the sugar when it's hot. When you add the sugar when it's hot, you're able to mix it in more quickly. And you can also mix in more, get it really sweet. However, if the temperature goes down, added too much sugar, that can cause some of the sugar to fall out of solution. See that as the sugar actually forming like little crystals in the bottom of the drink after it cools down. You can do this with salt water as well. As the water, if it's really hot, you put in a bunch of salt. As that water cools down, the salt will actually sit on the bottom of the solution in the cup, whatever you're using. And that's just because the amount of the substance that could be dissolved decreased. So why does temperature change how much of a substance can be dissolved? Well, as the temperature is higher, the molecules move more quickly. So when the substance is cold, the water actually has a hard time going in and breaking apart the atoms from one another in these ionic compounds or in the molecules, separating them out from a big clump. And the water has to work really hard. However, whenever the substance is hot, those same molecules are going to be going real fast. And they're going so fast, in fact, that if it's an ionic compound, sometimes they'll just kind of separate from each other a little bit on their own, and then the water can sneak in and break them apart. However, if we're talking about a gas going into a liquid, it's kind of the opposite, because gases are already moving very fast. They move very quickly. Remember that gases want to escape their container if it's open, or they'll fill their container if it's closed. If we want to make something like soda, and we want those bubbles to stay in the water to form our soda, we actually have to have a decrease in temperature. That's because those gas molecules will go from being really fast, kind of escaping that container, escaping that liquid, to bumbling around, just going very slow, sitting in that liquid. Maybe every once in a while one will escape, but we can go a step further and push those escaping molecules back in. We do that with pressure. So you might have heard of sodas being bottled under pressure. Pressure is just how much you're pushing down on the substance. So it's going to press down and keep those gas molecules in the liquid. And then once you take off that little cap from your bottle, hear a fizz, sometimes a pop. If you've shaken it up a little and added some extra pressure to help some of those bubbles escape, sometimes that little shoot right off. So the fizz and pop happens because that bottle is already under so much pressure from the gas that's sitting on top of that soda. So there's actually gas sitting right here, keeping it pressed down. Open the bottle of soda. If you sit it out on a hot day, it goes flat more quickly. Whereas if you were to sit it back in the fridge, or you have it in a cooler or with some ice, it stays fizzy longer and it goes flat, or less bubbles, more slowly.